Hello folks, we are once again back with this exercise 7.3 problem number 21, which says that I equal to sine inverse cos x dx. Apparently the problem looks quite complicated, but actually since you know quite a lot of inverse trigonometric properties, we can use that and try to make it as simple as possible. So we are all aware of the property that um, sine inverse of theta plus cos inverse of theta is pi by 2. We know this property. So because of that, sine inverse of cos x can become pi by 2 minus cos inverse of cos x, by the same property, because cos inverse of theta will go on the other side, and here your theta is cos x. So like that, you get this whole thing converted like this. Your I now becomes, instead of sine inverse of cos x dx, we can write pi over 2 minus cos inverse of cos x dx. Now, the good thing about this is cos inverse of cos in this domain is going to be just that x. We know it. So it's just that x dx, and then we can find the integral. Integral of pi over 2 is a constant, so only dx, x dx. So here it is pi over 2x now, and this is going to be x squared over 2 plus c, only that much. Since we've used the property, it's only that much. Can be done by other methods also, but then that is going to only be a little more complicated. Why? Because you don't use the property. That's it. So once you do it like that, we can move to the 22nd problem, which says that I is integral of dx over cos x minus a times cos x minus b. Again, this is sufficiently complicated, as I told you, because we don't encourage much of the products in the denominator. That is only going to not make things so comfortable. So obviously we are going to use some transformation by which these things are going to get either cancelled or something like that, like how we did in the previous case, the one before, where we converted it into tan and divided by cos raised to 4 or something like that. So we are going to do something like that so that this whole thing becomes more simple. So for that, let's consider this separately, and then we'll come back to the integral. Consider 1 over cos x minus a times cos x minus b. Now for our simplification, let's multiply both the numerator and denominator by cos a minus b. You'll soon know why we are doing this. Denominator also you multiply by sin a minus b. Since you're multiplying both numerator and denominator, there's no change in the value. Now what we are going to do is, the numerator sin a minus b, for our convenience, we will write it as sin x minus b minus x plus a. Just check this. If you carefully look over here, plus x minus x will cancel each other, and a minus b will stay. So actually it is a minus b, but we have written it in a different way. Now, because you know that sin c plus t is always sin c cos t plus cos c sin d. So let's use that. So this is actually sin x minus b minus x minus a. Okay, so we'll use the minus transformation, times in the denominator x minus a, x minus b, and sin a minus b. Sin a minus b is a constant because a and b are constants. So we are using the formula sin maybe x minus y. So that's going to be sin x cos y plus cos x sin y. So let's use that. So we are going to get sin x minus b cos x minus a plus cos x minus b sin x minus a, and all these things are in the denominator. You have cos x minus a, cos x minus b, and sin a minus b in the denominator. You can take the 1 over sin a minus b overall outside. Why? Because it's a constant. So let's pull that out. So we are left with these two terms, which is applicable to both the terms here. So you are getting sin x minus b times cos x minus a, with the denominator cos x minus a cos x minus b. We have pulled the sin a minus b overall out because every time we need not write it. Same way for the next term, it is cos x minus b sin x minus a, and then we have cos x minus a cos x minus b. Now why we do this? Because there are things that is going to get cancelled. So this is going to get cancelled and this is going to get cancelled, so that you are left with 1 over sin a minus b, and then here we are left with tan x minus b, and the next term is going to be tan x minus a. Okay, so now let's come back to our integral. Integral now is going to be this thing. We have got it converted as 1 over sine a minus b, overall common that can go out, and the other terms in the integral is going to be tan x minus b plus tan x minus a dx. So that way it is 1 over sine a minus b. We have the integral of tan x minus b dx and tan x minus a dx. So we know that tan integral is going to be log sec. So this is going to be log modulus sec x minus b, and this is going to be log modulus sec x minus a, which you can further work with and get it converted maybe into cos or so. Yes, because there is a minus, this is a minus sign. In cos it is reversing, only in sine it will stay as it is. So this will remain as minus, so that minus will carry everywhere. It's in between sign, it will stay as minus. That will get carried everywhere. So if you want, you can do one more step, that it is sine a minus b. It can be log a minus log b is log a over b. So if you want, you can write it like that. So it is like sec x minus b over sec x minus a plus c. Then sec is 1 over cos. So that way you can even convert it into cos and then write it the other way around. So that's all. So that's how you can further modify this. So this should be all for this video, where we have now completed the entire exercise except for the MCQs. There are 2 MCQs also there. So that will be our next task. In the next video, we can have the MCQs. Thank you.